The question says E and F are the points on the diagonals of a parallelogram ABCD such that AE is equal to CF, and we need to show this figure BFD is a parallelogram. Now clarity will come when you draw the figure. Say if I make a parallelogram and I name it as ABCD as per given in the question, it is given a parallelogram. Now we are given a diagonal and some points on the diagonal. So the diagonal AC, let's say I've drawn this diagonal AC, and we are given 2 points E and F. E and F, right? On such that CF, that means, let me name this point first. This is AE and this is CF. We are given AE length. We are given this length. AE is equal to CF. Right, and then we have to join these points to obtain a parallelogram, that is BF. So BF, this is BF DE. DE, that means we need to prove this figure a parallelogram. So let's shed the triangle parallelogram. We have to prove this figure a parallelogram. Now we can do it in 2 different ways. Let's say begin with we can prove these 2 sides equal and these 2 sides equal, and therefore we can say that it is a parallelogram. The other way could be proving this, their diagonals equal should be shorter one. Let's say if I draw the other diagonal, we know that diagonals of parallelogram bisect each other. So that way I can say that AO is equal to OC. This is because the diagonals of parallelogram bisect each other. Now further you can see that we are given AE is equal to CF. Now say this is equation 1 and 2. If I subtract these two, that is AO minus AE should be equal to OC minus CF. So what is AO minus AE? Should give you this, that is OF. This OF. OF. And this is, sorry, this is OE. This is E here, right? So it should be OE and the other is OF. So these two are equal. Now check here. OB and OD are already equal. OB and OB is equal to OD. OB is equal to OD. Now look into these 2 points. From this shaded quadrilateral, as you can see, we prove their diagonals bisect each other, right? Since the diagonals of the quadrilateral BFDE bisect each other, therefore BFDE is a parallelogram. So whenever you prove the diagonals of a quadrilateral bisect each other, this becomes a parallelogram. The alternate was proving these 2 triangle congruent and writing this sides equal to this, and similarly proving this triangle congruent to this, we could have proved this is equal to this, but that should be a longer way.